My name is Eddie Mendoza,
My name is Dre Dawson.
and this is our project called Mudfix. A fraction of this information here is in this binder, so we'll show you that later on.
So our question was, how would organic potting soil affect the way that electrical charge comes out of a fuel cell? Our hypothesis was the natural sand soil because we were thinking since it's all natural from the actual ground, that if it was not tampered with, it would produce the most electrical charge.
So the procedure for this project is to step one, prepare your first prepare your 3 different soils. And so the first one is regular potting soil. The second one is sand soil, and the third one is basamic soil, which abbreviates to PATEN. Potting soil exposed to Martian-like atmospheric conditions. So first you place a plastic strainer or recliner over a large mixing bowl. Then you measure a total of about 4.5 cups into a measuring cup. And then you gently shake it over the strainer over the mixing bowl, so that the soil is strained and it does not have any small hard rocks or twigs or something like that, which can possibly mess with the microbes in the vessel. And then you add distilled water to make the soil wet. It has to be kind of like a cookie dough feel. And the dirt, and then you carefully take the microbial fuel cell pieces out of the box.
With gloves on.
And then lay them out. Identify different objects and things that will be needed. And use masking tape and a permanent marker. So we can write out here, as you can see here, what soil it is. So step 4 is to put the nylon gloves on so we won't contaminate whatever's in them. And we start assembling the first MFC. Step 4 is to take out the green wire and the orange wire that came with the microbial fuel cell, and then we enter the green wire into the anode which looks like some kind of a thin piece of circular fiber, and we stick the green wire through. And then we take the orange wire, which we stick into the cathode, which is like the same thing as the anode, except thicker. So by doing that, we have to straighten out the wire so it can be at a 90-degree angle like that. And the exposed part that's not covered in the plastic thing has to be straightened out so it can stick. We fill in the vessel with dirt up to the 1 centimeter mark, and then we enter the cath anode in, and then we fill it up to the 5 centimeter mark. There's a bow right here, and then we put the cathode in. So and then we'll repeat these steps on 5 and 6 for the rest of the microbial fuel cell, which goes with that right here.
And then after you put the anode and cathode in with the mud, you wait 5 minutes for the water, and then you dump out the water, and then you get the wires, you stick them through the holes on the lid, and then you make the hacker board with the LED capacitor, and then you connect the wires onto the hacker board. and then you have to wait a couple weeks for it to start showing results.
And the LED goes in ports 5 and 6, and then capacitor goes in ports 1 and 2. As you can see here, the cathode wire, positive port, and the anode part goes into the negative port. Is that all? Yep, and that is how you set up the microwave fuel cell. So the materials used for this project and procedure was a microwave fuel cell kit, which includes three MFC vessels, 3 anodes, 3 cathodes, 3 hacker boards, 3 capacitors, 3 LEDs, a digital multimeter, and a pair of Nairo gloves, which we also had extras. Stuff that did not come of the kit that we had to get on ourselves was the organic potting soil, natural sand soil, and the balsamic soil. And also the Steve plastic strainer, a glander, which we had to bring ourselves, mixing bowl, measuring cups, distilled water, paper towel or rag, masking tape, permanent marker, stopwatch, a loud notebook, and a small shovel. So let's skip out the bit. So our dependent variable is the power output of the electricity, and our independent variable is the soil that we'll be using.
Our control was the potting soil because it will work as great way to differ between the sand and the motion. It's the way that we can tell the difference. And those are some of the resources that we used.
Such as purchasing the kits and learning what these MFCs do. So for our data, after a week and a half of measuring the power capacity and resistance, measured in ohms, so each microwave fuel cell had five different tests of 18 days. So in the first day, the potting soil measured in 5.37 ohms. The second day, the sand soil, the first day, the sand soil was 3.30 ohms. And the balsamic soil was 4.85 ohms. In the second day of testing, the potting soil went up to 6.6 ohms. The sand went to 6.2 ohms. And the balsamic soil went to 5.53 ohms. Third day, the potting soil went to 6.25 ohms. The sand went to 6.20 ohms, and the balsamic was still at 5.53 ohms, as well as the sand too. Fourth day of testing, the potting soil was at 5.98 ohms. The sand was 5.26. The balsamic soil was 3.79 ohms. And the final day of testing, the potting soil measured 6.18 ohms. The sand soil measured 6.05 ohms. And balsamic soil measured 5.20 ohms. So, looking at this data, we found the mean, median, mode, and range for all of the different soils. So for the potting soil, the mean, which is the average, which is how we find that is by adding them all up, then dividing it by the amount of how many numbers were there. So the mean for the potting soil was 5.956. The median, which was the middle number of all the testing, is 6. The potting soil did not have a mode, and the mode is that the number that shows up the most. But all of them were different. And the range between the smallest number and the highest was 0.88. Now for the sand, the mean was 5.402, and the median for the sand was 6.05, and the mode was 6.2, and the range between the smallest and the largest number was 2.9 ohms. So, and finally, our Balsamic soil, the mean was 4.98 ohms, the median was 5.2 ohms, the mode was 5.53 ohms, and the range was 1.74 ohms.
Some observations that we had during this testing was the potting soil and sand were already giving off energy, even though it said it might take a couple weeks to start producing. And in the sand, Michael fuel cell, there were extra water, but when we went to drain it, nothing came out of it. And then water bubbles started appearing on all the different MFCs, and it's a common reaction. The common reaction between all of them was when we started testing, the lights started randomly blinking. We don't know.
And that's really what we wanted testing. Pretty interesting.
Our conclusion is that the potting soil that made the most electricity, and it proved our hypothesis wrong because the potting soil produced the most and the sand soil was about the second.
Our future direction for this project is that a continuation to this experiment we're conducting is to try to make a microbial fuel cell from chemically similar Martian soil. We will also expose the Martian simulated soil to Martian atmospheric conditions by flying soil in a high altitude balloon, and then trying to make a microbial fuel cell out of the foam dirt. In case you haven't seen the graph right there. And here's our abstract of our whole project. We have pictures of us preparing the soils.
That is the Balsamic soil from when we got it back from the atmosphere. It was actually still very cold when we got it out of the box.
So that was interesting, and that was 2 days after this fall.
Yeah.
And then that's ours, us removing it. And this is the Martian soil, which is going to be for our future direction in our continuation of this project.
Which that one, we already made one that is just normal, and then we're also gonna send, on the 16th, we're also gonna send some up into the atmosphere, so we can see if that affects it also.
So we already have a cell made for that one, which is testing right now, and will be ready in the future. The simulated Martian soil percentages, you can see like what elements is made out of right here. and comparing it to like what real soil is on Mars. So that's the closest we can get to it. It's kind of dangerous. So that's just also. So we had to wear a respirator just for safety, so we don't breathe in the dust.
That will be the Martian soil that we're sending up into the atmosphere.
So. What?
Actually, during this project, Eddie decided to make a science fair journal, and he charted every single thing that we did on every day that we did something.
So it's just a brief overview of what we did every day, so
There's multiple pages of it.
there's like, don't know if you want to read
If you
read
want
it
to
all
read
through,
that,
but
you can,
we'll just say that we did
you can let them read.
if you like. There's like 3 pages.
Okay.
So, are we gonna go?
Do you guys
So-
have any questions?
Oh, yeah.